Okay, so I ran out of time to finish this example in the last video, so I'm just going to wrap it up in this one. So this is where we left off. The next step is for you to find the marginal rate of substitution. And what I was saying at the end of the last video is that food is the horizontal good. We're going to find marginal rate of substitution, we're going to do marginal utility of food over marginal utility of housing. So go ahead, take a second, try to calculate that. I'll put up the answer and you can put yours in play pause it. Okay, so here we go. This is the marginal rate of substitution. I skipped the step where I wrote this as marginal utility of F divided by marginal utility of H. I went directly to the part where you multiply by the reciprocal. So this, in my work, is marginal utility of F. And this piece is the reciprocal of the marginal utility of H. So you multiply those, you get 0.8H over 0.2F. When you divide 0.8 by 0.2, you just get 4. So the marginal rate of substitution is 4H over F. Okay, so the next step is to set the marginal rate of substitution equal to the slope of the budget constraint, and that's what I'm going to do. So go ahead and do that, and you don't need to put anything in play positive at this point, so but go ahead and set them equal. Okay, so here I set the slope of the budget constraint equal to the expression we got for marginal rate of substitution. I just cross multiplied and got to F times PF equals 120 times H. The next step is to substitute into the budget constraint and get everything in terms of the same variable. So go ahead, and what I want you to try to do in the next step is to write the budget constraint so that it only involves F and PF. So try to substitute out and get rid of all the H's. Just so we recall, the budget constraint is 30 times H plus PF times F. Whoop, that's a bad F. And our income was $1,200. So go ahead and try to use some substitution from what we've done so far and get this in terms of just F and PF. So put that in play posit, and the solution will pop up in a second. All right, so here's the rest of the problem. So the first thing I did was actually over here. I picked up where we left off over here. I solved for H, and then I plugged that in to the budget constraint. So this term is what I plugged in for H. So now everything is in terms of PF and F. I just simplified from there. 30 goes into 120 4 times. So that's where this 4 came from. So then the next step, I just multiplied everything through by 4 to get rid of the fraction. So you get PF times F plus 4 PF times F is equal to 4,800. Now these two terms here are like terms. We've got 1 PFF plus 4 more PFFs, which gives us 5 PF times Fs in total on the left-hand side. And then to finish off the demand function, you need to get F by itself on one side. So you just divide both sides by 5 times PF, and you get that your quantity demanded of food is equal to 960 divided by the price of food. Okay, so I think the next slide is just confirming the right answer. Did we get it right? Score. So the demand for food is given by 960 over the price of food. So that wraps up this presentation. I think we'll go out with a song that probably expresses everybody's mood after doing that much math.
It might seem crazy what I'm about to say. Sunshine, she's here. You can take a break. I'm a hot air balloon that could go to space. With the air, like I don't care, baby, by the way. Because you, don't waste your time. Here's why. Because I'm happy. Clap along if you feel like a room without a roof. Because I'm happy. Clap along if you feel like happiness is the truth. Because I'm happy. Clap along if you know what happiness is to you. Because I'm happy. Clap along if you feel like that's what you want to do. Hey, bring me down. Can't nothing bring me down. Your love is too high. Bring me down. Can't nothing bring me down. I said, tell you now. Bring me down. Can't nothing.
I'll see you all soon. Stay happy.